Okay, this is the 2018 AP Calculus AB free response number 3. Number 3 refers to, this is no calculator, this graph. And so I'm not going to draw the graph on my whiteboard, but have that ready to go and refer to. And this is, not only is it a graph of G, but if you read through the description, it's also a graph of F prime, because G is the derivative of F. So we're going to be able to answer questions about concavity, increasing and decreasing, things like that, concave up, concave down, from this graph. All right, and we'll also answer some questions about G as well. So part A says, f of 1 is equal to 3. What is the value of f of negative 5? So if you have a graph of a derivative, this is how you figure out the value of a particular point on the graph of the original function, f. Okay, you start out with the y value at x equals 1, what you're given. So 3 plus, and then we're going to integrate from this value, this x value 1, to the value we're trying to get to, negative 5, of the graph of the derivative, which is g of x dx. We need to reverse those limits of integration. So if you reverse it, you have to make the integral negative. So negative 5 to 1. We would need the smaller one on bottom. So now we've got to figure out the area under the curve from negative 5 to 1 of g of x dx. So that's going to be 3 minus, and then I'm going to figure out the areas of the different parts of the graph. So from negative 5 to negative 2, you see that we have a square. All right, negative 5 to negative 2, and it's a 3 by 3 square. So it's below the x-axis, so that area is negative 9. So we've made it all the way from negative 5 to negative 2. Now from negative 2 to negative 1, we have a triangle with a base of 1 and a height of 3. All right, so that's 1/2 base, which is 1, height is 3. Okay, so that's going to be, and it's below the x-axis, so minus 3/2. From negative 1 to 0, there's no area under the curve. It's a straight line at the origin, so we don't have to add anything there. And then we're going to 1, so from 0 to 1, we have a triangle. 1/2 base, which is 1, times height, which is 2. So that gives us an area above the x-axis of 1. So that's going to be 3 minus, and this is going to be negative 9. So negative 18/2 minus 3/2 would be negative 21/2, plus 2/2 would be negative 19/2. A little bit of a pain. So 3 plus 19/2, so that'd be 6 plus 6 over 2 plus 19 over 2 is 25/2. All right, so a little bit of a pain there, but you can do it. I definitely could see one like this being on the 2020 test. Maybe not quite as long, but that is in the wheelhouse of what you might be asked. Part B says evaluate 1 to 6 of g of x dx. Okay, so this doesn't have anything to do with f of x. We're just looking at the graph of g. So we need to get the area under the curve from 1 to 6. Well, from 1 to 3, it's easy. It's just a square, a 2 by 2 square. Okay, so that's going to be 2 times 2 is 4. Plus, then we can integrate from 3 to 6, because that's a curve, of g of x dx. So again, how did I get to 4? From 1 to 3, it's just a square, so we don't need to use calculus. All right, 3 to 6, I've got to get the area under the curve. And I know that g of x from 3 to 6, so this is going to be 4 plus, the information in the problem tells me that from 3 to 6, g of x is 2 times x minus 4 all squared dx. All right, so that's going to be, we're just going to, since it's x, I can just treat it like a single variable there. And so it's going to be, we add 1, that's going to be cubed, x minus 4 all cubed. And I'm going to need a 2/3 out front. Okay, so 3 times 2/3 would give me 2, and then x minus 4 squared. So that gets you back to the original. We're evaluating that from 3 to 6. So that's going to be 2/3 times 6 minus 4, so times 2 cubed, minus 2/3 times -1 cubed. Okay, so 2 cubed is 8, times 2 is 16, so that's 16/3. -1 cubed is 1. Excuse me, -1 cubed is -1 times -2/3. That's going to be plus 2/3. So that's 18/3. So that part is going to be 6, but don't circle that. Don't forget about your 4 here. So plus 4, the original 4, the answer's 10. It'd be easy to go through all that work and accidentally circle 6 and forget about the original 4. I almost just did it myself. Okay, so A and B, very doable. If you need to pause, go ahead. All right, part C. So part C says, for the entire graph, what intervals, if any, is the graph of x, or graph of f, both increasing and concave up? Okay, well, it's increasing, and we have to justify our answer. So increasing where f prime is greater than 0. And it's concave up where the slope of f prime, because concavity has to deal with the second derivative, which would be the slope of the first derivative, the slope of f prime is positive, so greater than 0. So where does that occur? Well, it's above the x-axis from 0 to 1, and it also has a positive slope. And then it's above the x-axis from 4 to 6 and has a positive slope. So our open intervals, so open intervals we use parentheses instead of brackets, are going to be 0 to 1 and from 4 to 6. Right, so hey, that's not bad at all. All right, that's one you could get pretty quick. Part D says, find the x-coordinate coordinate of each point of inflection of the graph of f and give a reason for your answer. Okay, so let's take a look at this. The inflection point occurs where f prime changes, all right, excuse me, not where f prime, where the slope, sorry about that, of f prime changes signs. So let's see where that occurs. Okay, it doesn't change signs here. It's positive here. It's just slope of 0 there, positive there, slope of 0 there. Then it goes negative, so it is not at 3 if it goes from 0 to negative, because 0 is not a positive number. It happens at x equals 4 where it goes from negative to positive. Okay, so that occurs at x equals 4. So don't let it fool you at 3. If the slope is 0, that's not a positive. That's just a 0 slope. Okay, so there you go for number 3. Let's take a look at number 4. All right, number 4 refers to a table. I'm going to go ahead and write the table out. You may want to fast forward through this part. T is in years. And this is the growth of a tree, so the height of a tree. And that is in meters. So we've got 2, 1.5. 3, 2, 5, 6, 7, 11. It's getting pretty tall. And 10, 15. All right, so I wanted to go ahead and write that out. It's a lot easier for me to be able to refer to this. So part A says, use the data in the table to estimate h prime of 6. And then what's the meaning of h prime of 6? Okay, so what you need to do is get the slope between 5 and 7. So h prime of 6 is equal to, we're going to estimate that by getting the slope of the secant line for the values that surround 6. Okay, so change in y over change in x. So that's going to be 11 minus 6 over 7 minus 5. So that'd be 5 over 2. The unit is, just look at the table, meters per year. All right, and what does that mean? Well, that means at year 6, the growth rate of the tree is 5/2 meters per year. Right? That is, that's all it means. All right, let's look at part B, see if we can fit that in. It says, explain why there must be at least one time for t between 2 and 10, okay, that's the whole table, such that h prime of t is equal to 2. This sounds like a mean value theorem problem. So let's get the secant slope. It's going to be the change in y over the change in x. The change in y is going to be 15 minus 1.5. Excuse me just a second, the video hasn't paused. I think on number 2, part B, no, it does say between 2 and 10. Okay, so 15 minus 1.5, sorry about that delay, over 10 minus 2. So that's going to be 13.5 over 8. All right, I think I have done, that's not going to be equal to 2, obviously. So let me read over this one just a second. Sorry about that. See what the heck's going on here. It looks like on this table, between 3 and 5, I would get a slope of 2. So you would really probably have to check out all of the intervals to see, does any of the intervals give you a slope of 2? So let's look at between time 3 and 5. the secant slope is equal to 6 minus 2 over 5 minus 3. That's 4 over 2, which is 2. Okay, so we would have to look at each one of these intervals. The main interval, it doesn't give us 2, but between 3 and 5 it does. So the mean values theorem states, and they're going to want to see this written out, that at some time t, for a continuous and differentiable function, the slope of the tangent line equals the slope of the secant line. You might be able to write that more concisely than I did. But sorry for the delay there. I was looking at the entire process to see if the slope was 2, which it wasn't. But if any of these intervals the slope is 2, then the mean value theorem does apply. All right, so pause if you need to. I'm going to erase part A and part B. Okay. Part C says use a trapezoidal sum with 4 subintervals indicated by the data in the table to approximate the average height. Well, we know an average is going to be 1 over b minus a from a to b of h of t dt. Okay, so 1 over b minus a. So 1 over 10 minus 2 is going to be 1/8. Now we have to divide this into 4 trapezoids. So you're used to rectangles. The difference between a rectangle and a trapezoid is with the trapezoid, to get the area, you have to do the average height. Okay, so we have to get the average height for each trapezoid. So it's base times average height. I'll write that in. Area equals base times average height for each interval. Okay, so for this first one, base is 1. The average height is halfway between 1.5 and 2, which would be 1.75. For the second one, the base is 2, 3 to 5, the base is 2. Halfway between 2 and 6 is going to be 4. The third one, the base is 2. Halfway between 6 and 11 would be 8.5. The fourth one, the base is 3. And halfway between 11 and 15 is going to be 13. Great, so we get to do some nice mental math here. 1/8 times 1.75 plus 8 plus 17 plus 39. Dang. All right. So let's see. That's going to be 39 and 17, 49, 59 minus 356 plus 8 would be 65.75 divided by 8, and that's going to be meters. Do not try to do any better than that, my goodness. In fact, you probably could just put meters up here and circle all this. Oh, man. So that was kind of a butthole mental math problem. Okay, let's look at part D. Part D is it's worth going through. I don't know that you would have time to get through this on the actual test, but it's a related rates problem. And it says that the height of the tree is given by this function. G of x is equal to 100x over 1 plus x. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. What is the rate of change of the height of the tree with respect to time in meters per year at the time the tree is 50 meters tall? Okay, so for related rates problem, what we want, okay, the height of the tree is given by g, right? So we want the rate of change of the height, dg dt. Would have been nice if they'd have called it h, but I guess they did that up here. What we know, right, is that dx dt, and I'm using an x is the diameter of the tree, is increasing at 0.03 meters per year, so 0.03. We relate what we want to what we know. Well, they gave us the equation. G is equal to 100x over 1 plus x. And what do you have to do with related rates? You have to differentiate it with respect to t. So I'm going to move that way up here. So we have dg dt is equal to the bottom, 1 plus x, times the derivative of the top, 100. Derivative of 100x is 100. Don't forget dx dt. Minus, okay, so bottom times the derivative of the top, minus the top, 100x, times the derivative of the bottom. That's 1. Derivative of 1 plus x would be 1, but times dx dt. All over the bottom squared. 1 plus x all squared. Fantastic. So we got to plug in the values. We need to get, okay, what is x when the tree is 50 meters tall? We're going to have to solve. 50 is equal to, and then I solve for x, 100 plus x, 100 times x, excuse me, over 1 plus x. So that's 50 plus 50x is equal to 100x. So x is going to be equal to 1. So I know what to plug in up here. So dg dt is equal to 1 plus 1 times 100 times 0.03 minus 100 times 1 times 0.03 all over 1 plus 1 all squared. All right, that's 200 times 0.03, so that would be 6, right? Minus 3, 100 times 0.03 would be 3, over 2 squared is 4. So that's 3/4 the rate of change. So what would the unit be? Meters for height and year. Okay, so that would be meters per year. They really care about the unit, so get that. Make sure you carefully consider the unit. So, kind of a butthole question. I do think you could get A, B, and C in a reasonable amount of time. Part D is one you come back to at the end if you do have time. But related rates are definitely going to be on the 2020 test. You have to expect one of those. All right, and I will be talking to you when we work the next 2 problems on this test, number 5 and 6.